Okay guys, in Ionic Equilibria, let's understand amphoteric nature of water. What do you mean by amphoteric? Amphoteric means where it behaves like an acid as well as base. Alright, so here now when water reacts with ammonia, we already have learned that ammonia is a base. Alright, Lewis base. So when water reacts with ammonia, it gives NH4 plus OH minus. Now water reacts with base, that itself means water has to behave like an acid. So here water behaves like an acid. Obviously, as we have seen, this is our Lewis base, this is our conjugate acid, alright, and this is our conjugate base. Alright, okay. Now again, water when reacts with hydrochloric acid, it reacts with acid, gives you H3O plus hydronium ion, alright, and Cl minus. So here we get acid, here we get base, conjugate acid, conjugate base. So here water is reacting with acid, that itself means here water is behaving like a base. So water behaves like an acid here, like a base here. When treated with base, it reacts like, when treated with base, it reacts like an acid. When treated with acid, it reacts like a base. So that's the reason why we call it as amphoteric in nature. Water is amphoteric in nature. Fine. Now before getting into ionization of acids, my main concept will be of equilibrium constant. But before getting into equilibrium constant, we have got to understand ionization of acids and bases. Now it can be distributed into weak and strong. In weak acids and weak bases, some examples, all fatty acids, lauric, myristic, palmitic, stearic, oleic, linoleic, these are all fatty acids. Alright, or even if you talk in terms of methanoic, ethanoic, propanoic, butanoic, all those acids whichever are there, they are all those fatty acids are weak acid. Along with it, phosphoric acid, hydrocyanic acid, and there are many more such acids which are weak acids. You should be aware about it. Bases, ammonium hydroxide, all hydroxides of transition and inner transition elements are weak bases. Titanium trihydroxide, scandium trihydroxides, and varieties. And strong are strong acids, hydrochloric, sulfuric, nitric, these are all strong acids. Strong bases, sodium hydroxide, potassium hydroxide, calcium hydroxide, all alkali, alkaline, earth metal hydroxides are strong bases. So this is differentiation between weak and strong. Acids and bases, strong. Now what's the difference? Now, as soon as you put strong acid or strong bases in aqueous medium, in water, they dissociate completely. We write it like this, alright? Single arrow. Whereas when you put weak acids or bases in water, partly dissociates, and this is how we refer it, alright? So reaction, acetic acid, weak acid, dissociates, partly dissociate. This is how we forward, backward, this is how we represent dissociates to give you this. Alright, now when we talk in terms of equilibrium constant, what's the formula? It is product of concentrations of products of concentration of products divided by concentration of reactant. Got it? Generally we can write it like this. This obviously is fine. Okay, similarly if we are talking, and we mention it as Ka, equilibrium constant of weak acid. When we are talking of weak base, we mention it as Kb, equilibrium constant for weak base. Ammonium hydroxide is weak base. I have mentioned it over here, ammonium hydroxide, weak base. So backward, forward, ammonium plus hydroxide. So how do we mention? The same way. Here it would be base, and we would be mentioning here as Kb, product of concentrations of products divided by concentration of a reactant. This is how we mention it generally. So this is all about equilibrium constant Ka for acid, equilibrium constant Kb for bases. Alright.